And here we are making video number 2 of the morning. This one is all about just solving one-step equations using inverse operations. I will do my best to keep this short and sweet while still delivering quality content. Alright, inverse operations. We all learned in elementary school, I think, or at least it was taught. Please excuse my dear Aunt Sally. Although there may be mixed opinions and mixed emotions on this, it means parentheses, exponents, multiplication, division, addition, subtraction. What may or may not have been taught is these are really pairs of operations. Parentheses, exponents, each one undoes the other. Multiplication and division are inverse operations, so these are pairs of inverse operations. Addition and subtraction undo each other. We'll get to what that means in more detail here in a moment. For the purpose of this video and the level we are right now in math class, we're not going to worry about parentheses and exponents, but we are going to worry about these pairs of operations and how they undo each other. And in fact, we're going to learn to put this operation sequence in reverse, as you could imagine. So I got my notes off to the side over here. Don't worry. Okay, 4 examples. Four types of one-step equations we can have. We can have an addition, a subtraction, a multiplication, and a division. Those are our 4 choices with these basic operations. Let's start with addition. Here's an equation for you, one step, which means we have to do one thing to solve it. But we're learning a certain process in class, and here it goes. What do you see? You see addition happening. So how do we solve? With subtraction, the inverse operation, the other thing in the circle up here. Okay, so we're going to subtract 3, since that's what's being added to our unknown variable there. Well, the variable is known, but its value is unknown. So I'm going to do that inverse operation to both sides. Don't worry, Mom and Dad. This is clean content. But it's an easy way to remember what's happening here. So if I take 3 away, I just undid that addition, which makes a 0 and leaves me with x all by itself. That's what we're trying to do here, is isolate the variable. It does not matter which side the variable is on, but we want it to be lonely. 10 minus 3, 7. So there. We solved addition by doing subtraction. Why don't we use a different variable just to show you it does not matter what the letter is. It matters that it represents some unknown thing. What if it's a picture of a cupcake? It still represents some unknown thing. So, what do you see happening here? If you see subtraction, we're seeing the same thing. That's nice. So how do we solve? What's the inverse of subtraction? We solve it with addition. What are we subtracting? 5. So let's go ahead and add 5 to, what is it? Both sides. Some people put a little line down the middle, depending on where you were schooled or where you learned. But the bottom line here is inverse operations. Make that into a 0 when we're doing adding and subtracting, because those are opposites. And now we're left with y equals 15. So we solved a one-step subtraction equation by doing the inverse operation, which is addition to both sides. Done with that one. We have 2 examples left. I'm going to scoot up there. Don't worry, we'll come back and reveal the whole page at the end. Okay. Let's go green. Let's do a multiplication. Oopsie, spoiler alert. 4x equals 24. What operation do you see happening here? When you see a number and a variable right next to each other, that's a coefficient, which means it's like a codependent. They need each other to multiply to make this answer. Okay, so this is multiplication that we see. Let's look back up here. What's the inverse of multiplying? What undoes multiplying? Division, right? We see multiply, so we're going to solve with division. Division also looks like a fraction bar, of course. So here's what that would look like. 4 times x equals 24. If we divide both sides by that coefficient, there it is again, the both sides, this makes 1, so we're left with 1x. See it? There it is, 1x. And then we compute whatever your system is, and I get 6. So we saw multiplication, we solved with the inverse operation, which is division, to both sides, and we got a solution, a value for the variable. Let's see, I guess I'll finish. We'll finish in the black, which means we're now a profitable business. You could probably guess what's happening here since we've done addition, subtraction, multiplication. What's this going to be? Division. Yeah, sure. You are correct. So we see division. What's the opposite of division? The inverse operation? Right, multiplication. We solve with multiplication. So we need a little bit of room on both sides here. There's the both sides, the BS again. Life is full of it. There are 2 sides to every story, sometimes more. So I'm going to, since I'm dividing, this says x divided by 4, so I better multiply by 4 to undo that. And both sides. Now if that 4 was stacked on top of a 1, which is really what's happening with any whole number, and we multiplied these together, the kids these days, they like to say those cancel out, but what really happens is 4 divided by 4 is 1, so we have 1x. Camera adjustment. X equals 20. In a separate video, we learned how to check our work. I'm just giving you a short and sweet how to solve these things. There's 4 different types. We just did the 4th one. We saw division, we solved it with multiplication. And as a result of all this, instead of remembering the order of operations, for our simple place that we're in right now, we're not worrying about parentheses or exponents. And also the order of operations, we're doing them backwards. So it's really sad M. We're going to find addition or subtraction first, division or multiplication next. These are pairs of inverse operations. Addition solved by subtraction. Subtraction solved by addition. You get it. We're done. Thank you for watching, and I hope this helps you. And even if it doesn't, thank you for watching. Goodbye.